I think we go with Godzilla first. You lead with Godzilla.
Yeah.
Like Godzilla starts it, coffins end it. That's I think that's just a logical progression.
Oh God, I gotta get that on a T-shirt.
From ScienceSortOf.com, you're listening to Science Sort of.
Hello and welcome to Science Sort of. You're listening to episode 333. Our theme this episode is AGU Brought To You, which I didn't type correctly in the Slack, so I will have to edit that before finalizing the episode. My name is Ryan. Here to talk with me about things that are science, things that are sort of science, and things that wish they were science. It's Tim Dobbs.
Hello. Is this the show? Are we doing the show now?
We are in the show. We are within the realm of the show. How are you?
I'm doing well.
How are you? Where are you? What's going on?
Well, I'm in the beautiful Bay Area of California. And how am I? Well, you know, it's it's been a challenging year, but I guess if I'm gonna try to stay positive here, it was pretty cool doing the virtual AGU this year and getting to kind of go to that conference via various Zoom meetings and getting to talk to people there.
Yeah, so, one of the conferences that we traditionally try to cover here on Science Sort of is the annual meeting of the American Geophysical Union. One of the reasons it's a fun conference to cover is because of its absolute ginormous scale. When it's in person, we're talking tens of thousands of scientists, like in the 28 to 30,000 scientists all getting together, descending on Moscone or some other equally large conference venue. My joke, I like to usually tweet that like this is the time where we all get together and agree what the climate change conspiracy updates are going to be for the next year. All 30,000 of us in accord, no dissent among the ranks. And it's a conference that I really like just because there's such a huge different variety of disciplines represented, different kinds of science, a lot of space science, a lot of earth science, a lot of geophysics, obviously, and also a lot of really cool outreach stuff. And so, Tim, do we need to start off by talking about the fact that we wrote an abstract together?
Oh yeah, that's a great idea.
Tell us about our abstract, Tim.
Yeah, so we actually wrote an abstract, and Ryan presented a poster at AGU that we co-authored together about how to sound your best when communicating science. So I guess this episode is Appendix A for our poster that we presented at AGU this year.
There you go.
And yeah, it was a lot of tips about like, so what microphones should you use? What do you need a microphone if you're just talking to giving an interview? How to stand? Should you be far away from the mic or very close to the mic? Stuff like that. So I was actually really really happy with the way it came out because I felt like we were able to demonstrate a lot of sort of just basic technique stuff that I think could help a lot of people. So did we decide, are we able to make that available publicly, perhaps to the listeners of Science Sort of, or does that have to wait?
I will try to link to at least the abstract, and then from the abstract, you should be able to click view poster, and it should be available for viewing. And yeah, I would love it if folks are able to take a look at that. It sort of ended up becoming, and this makes perfect sense given what it is. It functionally sort of became a combination of some workshops that I've run in the past that are sort of like how-to podcast workshop, including workshops I've run at AGU at the fall meeting, in combination with Tim's audio production experience and the audio production guide that Tim sends out to potential guests of Science Sort of, who maybe have never done a podcast before. And so it was sort of both those things rolled up into one neat little package. And I love how interactive it is. Tim, made all these diagrams and recorded all these little snippets of audio. And yeah, I'm really proud of how it turned out as well. And we got some good feedback when we presented it virtually. And, people, I think, podcasting is as popular as it's ever been, I think. The irony being nobody has a commute anymore. So I'm not sure when people are listening to podcasts, but it's, yeah, I'm really happy with how it turned out as well, and I hope that people will be able to go view it and take a look at it and give us some feedback.
Yeah. If you are thinking about making a podcast, this could be a helpful tool. So I hope that works. Go make we all make podcasts and no one listens to them, I think, is the new rule, right?
No, we all have podcasts, and then any conversation at a party at some point has to include the phrase, "Hey, would you like to be on my podcast?"
Oh man, remember parties?
Right. I was listening to not to plug another podcast, and especially one that needs no plugging. I've been listening to some of the Conan O'Brien Needs a Friend podcasts.
Hmm.
They're quite good. He's very funny. It's this is not. I'm not breaking new ground here. But apparently, Sarah Silverman has a rule when she throws parties that no one is allowed to talk about their podcast at her party.
Well, that makes
So
so much sense. I feel like there's sort of two places where like you'd need to make that rule, and one is like Hollywood, LA, like the comedy scene is so big there, and the other is like science grad school parties or any place where someone is just like, oh yeah, no, I thought I'd make a podcast too, because why not?
yeah, well, I love that. Like she mentioned, that people like Mark Maron are at the party, and he's just grinding his teeth, not being able to invite people to come on his shit. So, but no, we like having people on our podcast. And speaking of Tim, you went above and beyond, man. You went and got some tape from around the
Yeah,
meeting.
yeah. Like a real radio journalist. It was a lot of fun. I've kind of done this before, but not that recently. I haven't done the old prep an interview and actually talk to people and kind of have them talk about their science like it's Radio Lab or something. So it was a ton of fun to go out and do that, and I sort of got lucky. I feel like in the interviews that I got, because all the interviewees were gracious and were able to talk about their science in what I thought was a pretty compelling and fun way. So.
So yeah, it's a rare experience for me to get to listen to content that's going to be going up on Science Sort of that I'm not on the microphone for. So it's been a cool experience for me to kind of wait for the results to come in from all your hard work. So which clip do you think you might want to start with?
Gosh, it's they were both great interviews, and I'm excited about both of them. But why don't we start with my interview with Amato Evan from the Scripps Institute, and where he talked about the Godzilla dust storm of 2020.
Which is like there were so many disasters in 2020. I didn't even know this was one of them.
Yeah, we were all so worried about murder hornets. No one told about the Godzilla dust storm.
The murder hornets never bothered me so much. If I'd known that there was I think I heard something about the dust storm, but I didn't know nearly enough about it. And so, with that, I guess let's head on over to your interview.
All right, so I'm here with Amato Evan at the remote AGU conference, Associate Professor of Climate, Atmospheric Science, and Physical Oceanography at the Scripps Institute. Amato, thank you for being on Science Sort of. Welcome.
Hey, thanks for having me.
Great. So we're mostly talking about, you recently worked on a study that is being presented at AGU this year concerning this provocatively named Godzilla dust storm of 2020. So maybe we can kind of start with, you can tell us a little about like, when did this dust storm happen and where was it and kind of how big was it? How did it get to be called Godzilla?
Yeah, sure. So this was a dust storm that emanated off of the Sahara Desert. It started in the early months of June and really ramped up towards the end of that month. And this would be June of last year. How this thing got the name Godzilla dust storm, I actually have no idea. And that would be a good bit of research for somebody to figure out like who decided to call it the Godzilla dust storm. But it was called that because it was basically this continuous wave of dust just pouring off of the continent for about a week. So much so that if you look at a satellite image of the Atlantic Ocean on a typical day, you see a bunch of clouds, you see a bunch of blue ocean, but just day after day after day, the whole thing looks brown. And it was just because there were tons and tons and tons of dust just pouring off the continent, moving across the Atlantic. I think at one point there was just a continual plume of dust that literally stretched from the coast of North Africa all the way into the Caribbean. And that was pretty unprecedented, just the sheer size and magnitude. I mean, it's just continental scale plumes of dust moving across the continent.
And so it was kind of starting in Africa and it was moving west. And when I think of like, when I watch the weather report, I kind of imagine the jet stream moves from the west to the east. So is this rare what it was doing, or is it just sort of a bigger magnitude?
Yeah, so the jet stream is essentially air moving from the west to the east, but that's a little closer to the poles. We're getting like a lot closer to the equator. So say around 10 degrees north, 15 degrees north. And so in that area, the air moves in the opposite direction. So from east to west when you get closer to the equator. So this is typically what happens. We get dust storms coming off of the Sahara Desert, and they're moving to the west. In the wintertime, they tend to get pushed towards South America. And in the summertime, they tend to get pushed up into the Caribbean. It's just really rare that there's so much that it's like a continuous plume of dust from Africa into the Caribbean, and then even, into Texas, for example.
Oh, wow. Yeah. So what's the way that you measure it to say that it is big? Is it just you look at the satellite picture and you say like, wow, it looks pretty big? Or is there, what are the tools and metrics we use?
Yeah. So you can get a qualitative picture of how big the dust storm looking at satellite imagery. We can get a quantitative measure of how much dust there is from satellites, and that works pretty well, but also from ground-based measurements. So there's a whole series of instruments. They're like mini robots that essentially it's like a little camera, and it's looking down at the ground, and then every 5 minutes that camera wakes up and it tries to find the sun in the sky, and it points at the sun and it makes a measurement for about a minute. And based on how much light that instrument is receiving, that tells you something about how much stuff is in the atmosphere between that instrument and the top of our atmosphere. And then you can convert that into a metric called aerosol optical depth, just a term that gives you an indication of how much that stuff in the atmosphere is interacting with the light from the sun. And that thing is actually then proportional to the mass of the stuff that's in the atmosphere. Okay, so that was a lot of stages here. So we have these little robots, they stare at the sun, and they make a measurement that gives us an indication of how much stuff is in the atmosphere. So not air molecules, but when I say stuff, I mean like particles, non-gaseous stuff.
Mm-hmm.
And so in this case, dust, but it could be smoke, it could be pollution from a factory or whatever. And we have a network of these things. I don't know how many there are, but NASA runs it. They're all over. I have one of these that's out in the desert just to the east of where I am right now. But we have some that are around the Caribbean. We have one that's just off the coast of Africa. And so anyway, these instruments were making these types of measurements, and the values they were recording were higher than anything I've ever seen. So high that it's like, you can go to where I'm at Scripps, you can go out to the beach on a typical summer morning and it's just super cloudy. You almost can't tell where the sun is just because it's so cloudy. It's still bright, but you have no idea where the sun is. It's just so cloudy. And these measurements were so higher than anything I'd ever seen, that firstly, the instruments, when they process the data, kind of the automated algorithms to kind of determine, are we looking at clouds? They thought, oh, this must be a cloud. They just threw away all those measurements in a sense. And then in addition, those values were so high that it's like, okay, this would have been, if you were just off the coast of Africa in one of these storms, it would have been essentially the equivalent of, being out at the beach on a really cloudy day, except that they weren't water clouds. It was just dust. Probably analogous to, probably analogous if you looked at some of those images from San Francisco during the peak of all the fires that we had here in California. And there were some pictures of San Francisco, and it basically looked like it was constantly dusk or constantly dawn, the same type of thing, except in this case, it was dust coming off of Africa rather than smoke from a forest fire.
Wow. So I want to make sure I kind of have the sensor image right. Basically, they're like little robots with sensors, and they're just kind of, there's a bunch of these around the world taking useful measurements.
Yeah, these things are just so incredibly useful. It's hard to overstate their importance to the field. So, right, there's all these.
Did they have a special name?
Yeah. Sorry, I should have said that. Yeah. So it's called AeroNet. It's the AeroNet network, or the Aerosol Robotic Network. So AeroNet. Robot seems like it's stretching it a little bit, but essentially it's just this little tube that has a camera in it, and more or less a camera, and it just wakes up, looks around, finds the sun, takes those measurements, and then goes back to sleep. And it just does that for every 5 minutes, more or less, throughout the time that the sun is up.
And does it have you say a little tube, is it sort of hammered into the ground, or like, if I were walking along, how would I see it?
let's see, it's about the size of a blender. I don't know, like a kind of big industrial blender, I guess. A
Okay.
blender you might see in a fancy kitchen. Yeah, and so uh, and literally, yeah, just a little tube that swivels on a base, and usually you have to mount these things a little bit off the ground, so they're not obstructed by anything. So when the sun is low in the sky, they can still see the sun. There's not a building in the way or anything like that. So we have one. Actually, the building that I'm sitting right now, we have one on the roof, for example. And so, right, how many there are right now? Gosh, thousands. There must be thousands all over the world. But this data is incredibly useful, for example, for climate models, right? So we have a climate model, and in our climate models, if we keep with the theme of dust, right? Dust affects the climate, and if as the planet warms, let's say that we start producing, for whatever reason, let's say the planet warms, things get dry, and we start kicking up a lot more dust. Well, all that dust that's now in the atmosphere, this extra dust from the warming, will have some kind of impact. It might, enhance the warming, or it might reduce the warming in some places. So we need to be able to simulate these aerosols and climate models and projections of global warming. And so you have these climate models, and you can almost think of it like you're sitting at a control board, and it's got these climate models have all kinds of knobs. And one of those knobs is like, how much dust should we produce? So the way they figure that out is they run the climate model and they compare it to this network of measurements, this AeroNet network, and then say, oh, well, we're producing too much dust or too little dust. Let me turn that dust knob in my climate model until I match what these observations look like. And so, that's why I say it's hard to overstate the importance of this network of ground-based measurements of aerosols, because, at the very minimum, like, that's how we have any confidence that our climate models are telling us, or at least able to produce aerosols, dust. It could be even smoke from fires or from pollution. This is how we get some kind of confidence that our models are doing something reasonable.
Right. Yeah, I wanted to talk about models a little bit. One of the things that was highlighted in your study was that all of this dust coming off of this big, we'll stick with the name Godzilla storm, was you would say, well, there's a lot of dust, and one hypothesis you could make is saying, well, that should cool the oceans and we should see less tropical storms this year, but that is not what happened. We actually had a lot of tropical storms this past year. And so that was kind of highlighted as in the study as like, what happened there? And so I was wondering how you were thinking about that, because it sounds like, yeah, you have to sort of build a model and it's quite complicated. So how do you go about thinking about what really happened there and making your model sort of work for the evidence in this case?
Yeah, well, so there's a couple parts there. One thing is that, gosh, where do you even start?
Yeah, good question.
Let's just start with
it's tough, right?
Yeah. Let's just start with the observations, right? So there's been a good bit of work suggesting that, hey, when you have all of this dust that's streaming off the continent, right? So you have the dust over the land, and if we want to think about how dust, like probably the main way that dust is affecting the climate, just imagine if you're looking at a satellite image of the Earth and you see like the yellow Sahara desert, and then you see the blue Atlantic Ocean. All right. So when we have a dust storm, when that dust is over the Sahara desert, still looks pretty yellow, not much of a change. But when that dust then gets pushed over the Atlantic Ocean, we go from something that looks blue to something that looks yellow, right?
Mm-hmm.
And what that is that's essentially energy from the sun. Right. The reason why the dust storm looks yellow is because it's light from the sun, specifically light, like in those kind of yellow, red, orange wavelengths, that's then reflected back out to space. And so that's energy that now is leaving planet Earth that otherwise would have gone into warming up the ocean. And so that's how dust cools off like dark surfaces. When the dust is suspended over the ocean, basically it's kicking all that energy back out to space. That's why we see it from the satellite images. That's what we're looking at. And the ocean gets a little cooler. So if we think about tropical cyclones, we definitely know that if you want to generate a tropical cyclone, you want to be somewhere in the tropics, where kind of the structure of the winds are pretty good, and you want to have a warm ocean. And because the heat in the ocean is essentially the fuel for that tropical storm. That's the thing that can make that storm really big. All other factors being conducive. And in fact, there's even like an observational limit, like that the temperature of the ocean has to be greater than 26.5 degrees Celsius before you can even form one of these storms. And that's been around for decades. So it stands to reason, hey, if you cool off the ocean, you should, if you don't have less storms, at least they should be less intense, but you should also maybe have less storms too. And there's been a bunch of work suggesting, hey, years where there's a lot of dust storms, we have less tropical cyclone activity in the Atlantic. And so then here's this year where we get we had the Godzilla dust storm, which was in the latter half of June. But I mean, the dust really was just going all month long, going crazy. It extended into July as well. And so you're thinking, all right, all of this activity is cooling off the ocean. We're really priming the ocean to be colder than average. We're priming the ocean to not be conducive to tropical cyclone activity. And there are also some interesting little feedbacks that can happen as well to reinforce that anomalously cool ocean. And then, the hurricane season shows up and it's just like, boom, storm after storm after storm after storm after storm. And it almost just like, hurricanes were just shrugging off everything else that happened. To me, that was one of the curious factors. Specifically, I guess, I've done some work in the past looking at hurricanes and dust and how those two things are related. And what happened this year suggested like, hey, it's like what I thought should have happened, it was the exact opposite. And so it makes you think like, wow, maybe we really don't understand what that connection is. Maybe the underlying physics, we just don't have a good handle on it. At least those of us that study dust and have had some kind of passing interest in hurricanes. So I'm sorry, I'm talking so long.
Oh, no. It's really interesting. Okay. I think what I'm kind of curious about is, I think you set the stage well for kind of like, okay, so it is intuitive that you would expect a cooler ocean, less hurricane. And then I loved your phrasing. The hurricanes just shrugged it off. Has very, what they might call 2020 energy.
Okay.
But, yeah, I think then my question is like, okay, so now when your theory kind of doesn't add up, like, where's your mind go? Like, what's your next step? How do you start to put together those pieces for something as complex as the atmosphere?
Right now it's so 2020, right? It's just like everything. I'm like so overwhelmed already with like my kids not being in school and like, everything else that's happening, like having no time for anything. And then it's like, oh my God, all this stuff that we thought was, this relationship that I thought, hey, this is a given kind of thing. Now it's like, that's not even working anymore. It's like, oh my God, it almost makes you feel like, you have to like start over again. Like, okay, let's go back here. And then it's like, who the hell has the time to do that right now? But it's almost a little overwhelming because it's like, oh my God, what's going on? So the first place to start would be, okay, let's take a deeper dive into what actually happened. And so I think probably in a couple months, we'll start seeing articles written by people that are really, really into hurricanes, don't really care so much about other stuff, but they're really into hurricanes. And they're going to be a couple articles kind of trying to dissect why this was such a crazy hurricane season. And probably from that, we'll start to try to pick out those components that may or may not be related to dust, to try to understand why it didn't really matter, like what happened. And so it's almost like a post-game wrap-up of like exactly what happened. It's just that wrap-up's not going to start for a couple months until people have a chance to really look at all of that data. That's probably going to be the place to start, to try to figure out where did these ideas break down. And to be like, okay, was all this work that we did, over the last 10 years, like, are we just wrong about all of that? And if that's the case, well, there you go. You can't really, that's okay. Can't fight it.
Yeah, no, I really appreciate that answer because it kind of highlights that, like, well, science is work. And, you're not right all the time and you just kind of go out there and try to see it. And sometimes you do need to try to rebuild your theory. So that's great.
Yeah, for sure.
So definitely I'll recommend to our listeners, if they want to learn more about this storm, you have a publication. I think this is through AGU Publications. Atmospheric Drivers of Major Saharan Dust Storm in June 2020.
That sounds about right in Geophysical Research Letters, yeah.
Okay, great. And yeah, we'll make sure we include links to anything that want to link there. Before I let you go, though, I was just curious. I wanted to just get I wanted to just sort of ask about your sort of path to studying. It sounds like you're, you kind of think of yourself as a dust guy, and I think our listeners would like to hear why. What brought you there?
Yeah. If I start, like when I was an undergrad, I got an undergrad degree in physics, and I had a professor that was studying comet tails, dust.
Hmm.
And so I started doing a little work in that, but physics just wasn't, I don't know, just seemed too esoteric. And at the time, I was very much interested in environmental activism as well. And so I was like, oh, which, doesn't vote. I don't, I almost hesitate to say that, but I just like being outside a lot. And so I wanted to kind of bring my interest in kind of the stuff that I started doing, is the research I started doing as an undergrad, kind of into planet Earth, not necessarily comets or anything, which are really cool, but just, I just wanted to tie my research into where I was. And so that's when I started looking at dust storms, saw some satellite pictures of dust storms, and was like, wow, that's kind of cool. And fortunately, when I was a grad student, I had a lot of liberty to kind of just go after questions that I thought were interesting. The thing that's cool about dust storms, though, is that you get to study a little bit of everything in earth science. And the reason why is because when dust storms start on the ground, right? And so if you want to understand dust storms, at some point you have to start learning a little bit about like soil science. You have to learn a little bit about ecohydrology. How does water move on the surface? Because, for example, you could take the mountains east of here where I am. If you get a big rainstorm, all this rain kind of in the desert east of where I am. And so you get all this rain and it just flushes all these fine sediments down off the mountains and into these long flat valleys. And then those sediments, once they dry up, this is the stuff that, they're really fine. And so then when you get a big windstorm that comes through, they can lift all these things up and push them out over wherever. Okay. So you get to learn a little bit about soil science. You need to learn a little bit about hydrology. Dust storms change as a function of the vegetation. So you have to learn a little bit about ecology, vegetation dynamics. And this is even before this stuff has gotten into the air. Once dust is in the air, right, you want to know, how does dust move from the surface into the atmosphere? And so this is like a subset of atmospheric science called boundary layer meteorology. You need to know like what's happening. There are even people that study just what happens at the top millimeters of the lower millimeters of the atmosphere, just right above the surface. All kinds of crazy, interesting dynamics there. And so then you need to understand, like, well, how does the atmosphere act when you're really close to the surface? And then that dust kind of gets pushed up out of that boundary layer, like higher up in the atmosphere, say a couple kilometers, 5 kilometers, and it starts getting moved all over the planet Earth, right? And so then it's like, wow, now you got to study climate dynamics and regional climate variability, and how does dust move once it's higher up in the atmosphere? And then there are all these interesting effects that dust has on the climate system. So we talked about one earlier, which was like how aerosols reflect sunlight back out to space. Aerosols, how dust does. How dust reflects sunlight back out to space. Dust also absorbs infrared radiation, right? So dust itself can get warm. And there's all kinds of crazy downwind effects. So sometimes carried within dust plumes, there are viruses, there's bacteria, and they get deposited all over the earth. When dust falls on the ocean, it's a source of iron. A lot of places, primary productivity in the ocean is limited. It's iron limited. So dust actually ends up being this important source of nutrients for biological activity in a lot of oceanic regions. Dust is also a source of phosphorus. There's a lot of dry tropical forests. Say like in the Yucatan, there are all these forests that their biological activity is limited by phosphorus. Dust acts as an input of phosphorus. There's all these human health impacts, right? That if you're interested in dust, so this study that I have out east of here, part of what we're looking at is the human health impacts of dust on the people that are impacted by these storms. And so, studying dust, I'm an atmospheric scientist, but it allows me to learn about geology, allows me to learn about ecology, it allows me to learn a little bit about human health, in addition to all and oceanography, in addition to all the cool atmospheric science stuff. So if you're someone that, doesn't, I like, doing inside baseball for my thing, but it's more fun to kind of be able to have this bigger picture view of like what's going on Earth. And so studying dust really is a vehicle for being aware of a lot of different fields and having your kind of foot in a lot of different pots.
Yeah, no kidding. I think you made a really strong case for it. I'm like, oh boy, should I start studying dust now? It sounds neat. um, Well, yeah, I think we're just about out of time, but yeah, I really want to thank you for coming on, and if you're open to it, we'd love to have you on again, maybe to talk about some of the stuff that you just laid out, because yeah, it
Sure.
sounds like a fascinating field of study.
Yeah, I'd be happy to. Just drop me a line.
Cool, great. Well, thanks for being on Science Sort of, and appreciate you taking the time today.
Yeah, my pleasure.
All right, so that was our discussion with Amato Evan. Thanks again to Amato for his time. I really loved doing that interview, and like I said in the interview, it made me so much more interested in dust than I ever thought I would be.
Yeah, it's wild to think about the scale of the issues at play there. Like, you hear dust coming over from the Sahara and changing the color of our sunsets here in the U.S. and the Caribbean especially. It seemed like, but it's really cool to have someone explain the dynamics of how that all works. And I I have a I have a suspicion that most scientists, and I think this is a good thing, most scientists, when prompted, can figure out ways to explain how their work is interdisciplinary and touches on a lot of different fields. But Amato made a super strong case for it.
Yeah.
One of the better arguments for an interdisciplinary science, all revolving around a mode of dust.
It's beautiful, really. It feels like you know, yeah, it feels like maybe I want to buy like a book of poetry about dust, a single mote of dust, and it's all about all the places it goes and how it affects everything.
I want Amato to analyze the end of Avengers Affinity War when half the world's population turns to dust, and I want him to tell me what would happen as all these dust particles float around.
We should bring back trailer trash talk for it. See if he'll talk to us for that.
It's a little late in the game for that, and I fortunately that wasn't something that was given away in the trailers. Maybe the trailer for Endgame would be a better choice there. But
Fair.
yeah. Who knew that dust could I don't know, just bring up so many interesting, cool topics to talk about. And great job with the interview, Tim.
Oh, thank you.
Yeah, you clearly were having a good time too, and that's the I think an interview like this one really highlights what I think is one of the strengths of our show in letting scientists talk about things in their own word, because you might not think like a dust cloud moving from the Sahara to the Caribbean is all that interesting, but when you get someone like Amato who is passionate and gets excited talking about it, like it's impossible not to get excited too. I think I think that's sort of that sympathetic nervous system that we all as a social primate have. We want, if we hear somebody else being excited, we want to be excited with them, and so it was a really nice way of being brought along for that sort of the excitement of the discovery and the kind of work that he was doing. And I do want to give a special shout out to Lauren Wood, who is works over at Scripps as one of their directors of strategic communications, and she has for years now hooked us up with really fantastic people to talk to from the Scripps Oceanographic Institute, because she appreciates the show and essentially at this point knows, like, we'll talk to any scientist who's good at talking about their science, and so she just pitches us really cool people to talk to, and we are really appreciative of that.
Totally.
So I want to raise a glass to Lauren. I want to raise a glass to you, Tim. And I want to tell you what's in that glass in our next segment. And that's called What Are We Drinking? Well, it would not be an episode of Science Sort of if we didn't also talk about what we are drinking. The sun has set over here on the East Coast. Would you like me to go first, Tim, or are you champing at the bit? Not chomping at the bit, champing at the bit.
I champ every day. Yeah, no, please go ahead.
I pulled out something that I think you're going to have an opinion on. It is a beer-based beverage from a little archipelago that I believe you're familiar with called Japan.
Ah, yes.
So this is a Kyoto Kizakura Kyoto Matcha IPA. Matcha? I don't know how to say it.
Is it like the tea?
It's the green tea with the whisk brush thing. Here's the thing, Tim. I've never had matcha ever, like in any preparation. I'm not familiar with it at all. It looks nice. It looks pleasing, but it just wasn't ever a trend that I jumped on. But when I saw that there was an IPA with it, well, now I'm interested. Oh my god, Tim, it's so green.
Yeah.
Holy. Hang on, I gotta call Julian to see this. This is wild.
It's that concentrated chlorophyll.
Julie, she gone? I think Julie's gone.
Maybe she got scared away. It was like, it's too green. I can't handle it.
It's insane. I'm gonna have to take a photo of this when I have a better lit situation. Okay, little freaked out by this. It looks like the joke St. Patty's Day beer. That's how green we're talking.
Does it have a head? Like, is there foamy
and that's
greenness
green
as well?
Yep.
Wow.
It's green all the way down. It tastes good though. It's very ooh, wow. So it's like it's very subtle in the hops as far as IPAs go, but it's definitely got that like herbal, almost floral minty ness. I guess that's from the matcha. I've never had it, Tim. I don't know about this. Tell me, you've been to Japan. Help me out here.
Yeah, did I have matcha in Japan? I don't know. I honestly, my green tea experience in Japan was sort of the trash person version of it, where there's vending machines everywhere at least in Tokyo, and so I would just be walking and I'd be tired because I was a tourist, and I'd walk past another vending machine and go, yeah, I should buy another bottled green tea. So I'd have like 6 a day, but matcha, yeah, I would say. Yeah, I don't know. What is the flavor? It's slightly bitter. Yeah, kind of herbal. Maybe a touch grassy, depending on it. So it sounds like you're describing all the same stuff. I wouldn't have said minty, but maybe if you add the hops.
Yeah, I'm just getting a little mintiness on it. This claims to be Kizakuro's first Japanese-style IPA. So I guess they're putting it on record that if you put matcha green tea in your IPA, it is now a Japanese IPA as its own distinct style. Which I can support that. That's fine.
This sounds great. I want to try this.
It's I'm sure you can find it out west.
Yeah,
it's imported by a mutual trading company in LA. So
okay, this isn't the one with the owl on it. That's the
that's
common.
That's Hitachino.
Yeah, Hitachino is the common import I see from Japan.
And they make great stuff. I just I think I've had them on the show before, and I saw this when I was out getting takeout, and just went ahead and grabbed it and stashed it in the fridge and saved it for a record day.
Totally, that's beautiful. I'm jealous, but yeah, we have, without talking to each other, actually got drinks on theme with each other, which is pretty fun.
Wow.
Shall I share with you what I'm drinking?
I'm desperate. I'm dying. I need to know.
I'm drinking a BarMatt Equatorial Ceylon tea liqueur. It's 35% alcohol, 70 proof. I saw this at my local, fancy liquor store, bottle shop, maybe more than a year ago. And I said, that's interesting. So what is it? And I guess they brew tea in water and then add alcohol. And I'm not sure how the extraction works exactly. But you end up with a 70 proof liqueur that says, if we look on the back here, it says, you can sip it neat or over ice, or show your creative side by using it in cocktails. And when I opened this and I tried it, and I said, whoa, that's very specific. And then I could not think of a way to drink it. And so it's been sitting there, and I don't hate it, but it's just very itself. And so I haven't actually had it in more than a year.
Is it sweet?
Well, okay, I'll take a sip now. This is I've had this before. I know what it's like, but I haven't had it in a long time. So let's review. It's so smoky. It's very smoky.
That sounds good, though. I mean, I feel like you could figure out a way to make a cocktail.
I mean, do you have any ideas? Because what I remember doing, it's not bad sipped, but it's quite smoky. So you want to have it on ice, or I want to have it on ice. And I remember trying to make like a Negroni with it, and it didn't really work for me. I don't know. Other ideas?
Yeah, for things that are like that strongly flavored, I tend to try to use those more as like an accent for a cocktail rather than like the backbone of a cocktail. So what I would suggest doing is maybe like a Manhattan, but you rinse the glass with this liqueur first. So you just put a little bit of this liqueur in the glass, kind of swirl it around, almost like you would use, almost like they sometimes do with vermouth to make a martini. But you do it with that, so then would get kind of that smoky, bitter tea flavor kind of permeating your Manhattan, but it wouldn't be the main note that cocktail's hitting.
Yeah, no, I think that's exactly right, because it's definitely, it's a little too much for me to be everything. But yeah, I like smokiness a lot. I'm into smoky scotches and stuff like that.
Yeah, or like something like this, you could almost also maybe think about it like freezing it into an ice cube with like an orange peel or something, and then just using that in a Scotch-based drink or an old fashioned or something.
Hmm. Well, see, this is
Yeah,
why I come on Science Sort of, is to get cocktail ideas.
to get cocktail tips from me.
The system works. Listeners, if you need cocktail ideas, just have some science you want to present to Ryan, and that's the trade.
Yeah, we'll provide cocktail tips for science. Is that what you're saying?
Yes,
The
yes,
trade-off here?
that's what we're sending.
You mentioned the smoky flavor of this liqueur. One way you could get some smoke would be wood. One way we use wood is in coffins.
Dun dun dun.
Tell us what you got coming down the pike for us this time.
Yeah, so this was a fun interview with Josh Bregy, who's at Indiana University Bloomington, and he studies paleotempestology, and so that's the study of
Tempestology?
tempestology. We're
That's wild.
we're studying storms, and the paleo means, any guesses, Ryan?
Past.
Mm-hmm. So Josh is looking at the storms that we've had over his data goes back as far as 500 or 600 years. So he's trying to figure out what were tropical cyclones like in the southeast United States going back hundreds and hundreds of years.
And I got to meet Josh very briefly in one of the Zoom happy hours I got invited to. So I'm a participant in AGU's Voices for Science program, which is an effort to basically get scientists just more comfortable doing different types of outreach and engagement. I'm on the Voices for Science policy track, which means that I'm supposed to be doing more policy level engagement, but it can still do stuff like this and count it towards my outreach efforts. And I point that out because applications for the next year's cohort is now open. So if there are scientists out there who are interested in having sort of a support network of participants and alumni and staff from AGU in honing some of your outreach skills, consider applying to be next year's Voices for Science cohort. I'll just say that since it's an AGU themed show, why not plug that program, right?
Yeah, well done. One of the themes of this show is about science communication, so I think it slots right in.
Yeah, and so I got to meet Josh at one of these, and he mentioned that he was a fan of the show, and I was like, "Well, that's great." And then he sent me a link to his abstract, and I clicked on it, and I was like, you're using coffins to study paleostorms? Hell yeah!"
It's so metal.
It is incredibly metal. I was so excited. So I'm really glad you got a chance to talk to him. Let's give it a listen.
Welcome back to our remote coverage of AGU, the American Geophysical Union Conference. Today we're talking to Josh Bregy. He's a graduate student in the Department of Geography and Earth and Atmospheric Sciences at Indiana University Bloomington. Josh, welcome to Science Sort of, and thanks for being on the show.
Thanks for having me on the show. I love it, and so this is a fantastic opportunity to chat with y'all.
Yeah, we're glad to have you here, and always glad to have someone have a fan on the show. So we wanted to talk about a poster you were presenting at AGU that was pretty neat. And the poster is titled 500 Years of Tropical Cyclone Precipitation Variability Along the Gulf Coast, Multi-Decadal Patterns, Trends, and Climate Connections. You got to have the colon on a good scientific study.
Right.
And so basically what we're talking about here is you've done a study using tree rings to estimate how much precipitation is coming from tropical cyclones over the course of approximately 500 years. Did I represent the poster well?
Yeah, definitely. Yeah, that pretty much sums it up. It's a unique study. It's the longest reconstruction of its kind, which is always exciting for paleo. And so, we can use a lot of this information to understand how extreme events change through time, but also what are the climatic drivers of these changes in tropical cyclones. So, it's exciting work in my opinion, but I guess I'm a little biased.
Yeah, I guess, so you sort of answered it a little bit there, but I think my first question was, okay, so why is tropical cyclone precipitation something we're interested in? What's the reason to want to measure that?
Oh man, I mean, there's so many reasons. So I mean, if you really think about it, if you look at the fatalities associated with tropical cyclones, inland flooding tends to be the largest contributor to that. And so, and where does that inland flooding stem from? Rainfall from tropical cyclones. So it's a really good idea to actually kind of see how the long-term patterns have shifted if we're in a period, say, where we have wetter storms. It's important information to know for hazard mitigation. Also does have some insurance implications too. So that's, I guess, a unique twist on it. What else? There's the fact that precipitation from tropical cyclones it's an important contributor to ecosystem functions and municipal water management. So I suppose this is a reconstruction that has a lot of stakes in it, if you will. So
Yeah, that makes sense. It touches on a lot of things. It sounds like about everyday life. So you used the word reconstruction a couple of times. Let me try to put that in layman's terms, and you can tell me if I'm wrong. But basically, what you're trying to do is saying, okay, we have a bunch of measurements over probably hundreds of years about how much rain came down from these tropical cyclones, and I want to see if I can then predict that without using the actual measurements. So I can look at something else and see if that is a good proxy for how much it rained. Is that a good explanation for what you mean when you say reconstruction?
Yeah. So we do use instrumental data, and we use that to actually calibrate or our measurements of a proxy. So in this case, it's late wood, which is produced. It's the latter half of a tree ring, and it's produced right in the middle of hurricane season. So we're basically trying to find connections between how much rainfall fell from a tropical cyclone over the season and how thick that late wood actually is. Then use that to, based off of the thickness of that band, to go back and see how much, or estimate how much rainfall fell from a tropical cyclone, say 400 years ago, 500 years ago, and go from there.
Okay, yeah, I saw this in the poster. You called out early wood and late wood, and so that's just a tree grows a certain amount in the early part of the year and the later part of the year. Is that a good way to think of it?
Correct.
Okay.
Yeah. So tree physiology is not my strength, and I'm I guess a little proud of that. But the early wood is produced so you have the growing season. Early wood is produced in the first half, late wood is produced in the second half, and there is a bit of a difference between the two, and I guess their function, though. Can I actually explain the function of the two? Not at all. I just use it as a tool. So
Okay, so then the tool that we're doing is basically you can measure, is it the thickness? Like how do we look at this tree ring and say, I know how much it rained in 1784?
yeah, so it's the thickness of that ring. And so with longleaf pine, the species that I'm using, what they're responding to are extreme precipitation. And so whenever you have an extreme precipitation event, you're going to increase your late wood production. So you're going to produce fatter rings, if you will. And so it just so happens that in this area, a lot of the extreme precipitation, at least during this time of the year, comes from tropical cyclones. So it's a perfect setup, basically, to try and reconstruct patterns of tropical cyclone rainfall.
Cool. So let's talk about how you actually got those measurements, because this is pretty neat. So you went down to, it was in the Gulf region, right? It looks like you're somewhere in Louisiana.
Yeah. So the wood is technically all from the DeSoto National Forest in Mississippi, right on that like little sliver of Mississippi that extends to the coast, not terribly far from the University of Southern Mississippi.
I see. And so you go down there, and what do you cut down some trees, or how do we get the actual wood that we want to look at?
So there's an increment borer that we use, and it's the least invasive, least destructive way to sample a tree. I'm sure it doesn't feel great. I can imagine somebody digging into you probably does not feel enjoyable. So, but the borer still, it basically makes it where we can grab a sample, we can go into the tree, grab a sample, and then the tree can basically heal back up over time. So we aren't cutting down trees. And so we're doing this for living trees, and then when we find stumps or fallen trees so these are all dead, we then take cross sections. We actually will cut that to extend our record back even further in time. And then it just so happens that we also had access to samples from a log cabin, the Decent House in Ellisville, Mississippi, and some wooden coffins. All of that wood was sourced from the same forest, so we could measure that after collecting it and actually extend our record back to about 500 years in this case.
That's very cool. And I don't want to let the coffin thing slip by because it's really metal. Were these coffins used, or were you like, well, I got to brush aside the skeleton so I can get at the wood? Or...
So actually, this wood was actually all collected before I even got into grad school. Okay. And the researchers actually didn't find a climate signal in it. And so I just decided to try just against tropical cyclone rainfall and found something. But the wood from the cabin and the coffins were collected for a different study, I guess a dendroarchaeology study to really get at the construction history of the Decent House. And the wood from the coffins is actually, or I guess the coffins are located at the Mississippi State Asylum, and that was collected partially for the dendroarchaeology study, but also for a bioarchaeology study to really get at the history of the patients, I guess, at the asylum way back when. I want to say in the early 1900s or so.
Oh, wow.
So, but I fortunately did not have to actually go out and collect any of that. I was still in undergrad and very undecided about my future.
So this is not a grave digging study.
No, unfortunately. I guess depending on your perspective, unfortunately. So.
Well, so I'm looking at you have a diagram on your poster here, which is really neat. Maybe we can find a way to give listeners access to this poster at some point, because there are a lot of great diagrams.
Oh, thank you.
So you have this diagram where you're showing that you've got all these different sources of wood, and you can look at the width of each of the rings, and you can actually overlap them. So you can see that, like, this wood was clearly growing between 1850 and 1875, let's say. And here's another tree or wood source that was also growing in that time, but then continued growing up until it looks like 1890-ish. And you can actually see that, the rings where the years overlap, the width of the rings also overlaps.
Exactly.
So then how far, so you've kind of reconstructed many, many years. How far back are we talking? So we've got like more or less modern times, and then how far back can we do these kinds of measurements?
So with this one in particular, we go back to about 1540, though I do have some samples that actually predate Columbus's arrival, which is super exciting. I guess always wanted to beat Columbus, so for some weird reason. But it's a little trickier to do that here in the eastern half of the United States, because so much logging and whatnot has taken place that when we do rely on log cabins, for example, or wooden coffins, we can extend our records back even further. I guess it's also kind of species dependent, but out west, it's not uncommon for you to get records extending back a few thousand years, which is awesome in general. Not as awesome for paleotempestology because of the lack of tropical cyclones that impact the area, or at least the relatively few tropical cyclones that impact the area. So, but yeah, so we can basically look at similarities in the rings to cross date them and extend our record back. And so several hundred years to several thousands of years. It just kind of depends on where you're at.
Nice. Yeah. And I want to hook on, you mentioned paleotempestology. This is one of those like, people should know that this is a field and it has this great name. Do you want to just give the one sentence summary of what paleotempestology is?
Yeah, so I usually jokingly say that it's like Jurassic Park, but with hurricanes. But I guess in all reality, it's trying to reconstruct hurricane activity and intensity and the climatic controls well beyond the instrumental record. So, and we use multiple proxies for this. And in this case, we're using tree rings, but I also use sediment for this. So, yeah.
Nice. Well, that's really cool. A lot of the meat of this poster is talking about correlations with your measurements compared with a lot of other sort of climate factors and precipitation factors and measurements that you have.
Mhm.
And the one that jumped out to me, this is not my area of expertise, but the one that jumped out to me is you mentioned trying to make connections with the Atlantic multi-decadal oscillation. Can you explain what that is?
Yeah, so you could almost think of it as the Atlantic analog to the El Nino Southern Oscillation. Though in this case, it's pretty much manifesting only as sea surface temperature anomalies. It does impact other circulation patterns in the North Atlantic, and I won't dive into those because that's a rabbit hole we don't need to go down.
Mm-hmm.
But so in this case, though, when we are in a positive phase of the AMO, we tend to have warmer sea surface temperature anomalies, and a cooler phase, corresponds to the opposite. And so, and this is, of course, cycles on multi-decadal timescales. So, at least 30 or so years for a cycle. That's usually the minimum estimate for that cycle. So, yeah, that's a very rough explanation of the AMO.
Okay, so there's a sort of climate oscillation that happens over this period of time, and we want to see if these tree ring measurements can help us figure out, tell us anything about how that oscillation happened.
Exactly, and what's the impact on tropical cyclones and tropical cyclone rainfall?
Right. So, do you want to kind of give the headline of what you found? Were you able to find a correlation there?
So we did find a good correlation, although we had to account for autocorrelation. It's that's the problem when you're dealing with long time series, and so we found that it's not the dominant control on tropical cyclone precipitation variability, but it is a factor, and what we suspect. Well, I guess the mechanism that we suspect is going on here is that the AMO is really controlling the size of the Atlantic warm pool. And that Atlantic warm pool really kind of controls the environment and whether or not it's conducive for tropical cyclone formation and maintaining intensity. So whenever the pool is quite large, generally you see a larger area where, say, vertical wind shear, so the change in wind as you increase in altitude, you see a reduction in that. And then we also see an increase in the exchange of basically, moisture and I suppose latent heat fluxes between the ocean and the atmosphere. So a large Atlantic warm pool is very conducive for tropical cyclone formation. And so during a positive phase, we see that warm pool increase. And so we should see tropical cyclone precipitation at our site increase as well. And we think that the loop current in the Gulf of Mexico, which is a warm water current that comes up through the Yucatan Straits and moves past Florida eventually and eventually goes up along the east coast of the United States. We think that that's also acting as basically an extension of that warm pool into the Gulf of Mexico. So when it's further north or farther north, we would expect tropical cyclone precipitation to also increase at our site. I don't know if that was much of a headline. I feel like that was more of an abstract.
It's a good abstract. I appreciate it. Yeah, I guess like, so I'm thinking about now, like, okay, if I'm an insurance adjuster and I need to, draw some conclusions I'm sitting there in Mississippi and, okay, well, what do I make of all this? It looks like the headline for me would be, okay, well, I can look at this study and figure out some tree rings to figure out how much I need to talk about, how much insurance someone needs for flooding.
Mm-hmm.
Is that fair?
Yep, I would say that is a more than reasonable assumption, and you can even extrapolate this out even further and talk just generally about tropical cyclone activity as a whole. So if we see that like that loop current pinch farther north, then you probably, I mean, people are probably going to want to get some flood insurance for that year, or I guess for a long time. I don't think you can buy just a year's worth of insurance. I don't know how insurance works apparently. So, but yeah. So that's one of the links there, if you will. I guess to just everyday practical applications of this.
Yeah. The other thing I see here, and this is just a quick glance at your charts. Everything does kind of tip up in the past 50, maybe 20 years. Is that a real effect? And is as my sort of uneducated eye, I jump immediately to like, well, that's climate change we're seeing. Is that fair, or is that not a fair question? Or
so we don't actually we aren't testing for climate change in this right now, because we're really trying to get at more of the natural variability. But I think that's a reasonable next step to go. I can't really comment on whether or not that uptick is attributed to climate change, or if it's a natural pattern. But I will say that at least we do see a significant, slightly positive trend in the frequency of years, basically, where we do have extreme tropical cyclone precipitation. So just kind of food for thought, I suppose. But the attribution side of that we haven't explored in this paper. So
yeah, that's fair. I don't want to try to corner you into making conclusions that your science doesn't bear out. But it was just something that I saw really quickly and was like, well, that could be something.
Oh, yeah. Well, and I think it stresses the need to actually go out and really develop a network of these proxies, so we can actually start to say whether or not these changes that we see in such a nuanced component of tropical cyclones is actually attributed to anthropogenic climate change or not.
Could you predict, with these kinds of proxies, can you then say like, well, here's how much we think it will rain in 2050?
Yeah, so there's a whole field of paleoclimatology that focuses on proxy system models, and it's really just trying to incorporate proxies into your models so you can, one, represent the dynamics of past climates, but then two, kind of take that out and look at the projections as to how are tropical cyclones going to change in terms of landfall, how are they going to change in frequency or intensity, even the hazards associated with them. Are we going to transition to more of a precipitation dominated tropical cyclone climate, or are these storms going to just speed up and we're going to have a lot, like really high storm surge? So yeah, there's a projection component for sure. And so I hope to explore that down the road once I've solidified a tenure track position.
Well, I know we've really skated along the top of this study. Is there anything else you want to touch on talking about this study at all? Did we miss anything?
Actually, yeah. With paleotypology, I mentioned that there are different proxies that are used. Sediment has been like the gold standard. Tree rings are starting to become a little more popular, but this is a very unique way to actually reconstruct tropical cyclones. But a big thing or a big issue in paleotypology is the fact that we really lack multi-proxy reconstructions, where we compare proxies that are typically thought as like completely unrelated to sediment and tree rings. And so I start doing that actually in this paper, just to kind of explore that and get the ball rolling with the paleo hurricane community, because I think these proxies do complement one another. And we can kind of see that actually in what I think it's figure 12, that my record does kind of show some active intervals that align with some of the sediment records. And so it's something that I'm really excited to explore in more detail, and I think is something that a lot of emphasis needs to be placed on, because proxies say different things and they differ from models sometimes. So if we can find a way to systematically compare and I guess synthesize records, then we will have unlocked a huge part of really just paleoclimate as a whole.
Right. Yeah. Well, okay. The call is out. If anyone out there has additional proxies to bring, we can Is it, you're talking, it's basically like a belt and suspenders situation where it's like, well, the more different ways we have of talking about this or learning about this, the more kind of the better picture we have overall.
Exactly. So we can basically get a multidimensional perspective on tropical cyclones, or really any kind of aspect of the climate. But in this case, tropical cyclones, because we have, with my stuff, precipitation reconstructions. With sediment, it's often reconstructing storm surge height or wind speeds. So yeah, there's we can holistically look at these hazards and better understand how they're going to change.
Right. Yeah, and kind of on that note, I noticed that you did in your poster you linked a GitHub repository that it looks like you published.
Oh, yep.
It looked like this was kind of very modern open science kind of approach. I was just sort of curious what your experience has been like with trying to push stuff out on GitHub and use that collaborative method.
So it's a little, I'm a little new to it. So that GitHub, I guess, project, I don't even know the right term, but that is actually the instrumental data set that I developed to calibrate this record. I basically just extracted tropical cyclone rainfall from an already existing precipitation or gridded precipitation product. And so, that's been essential. I guess it's laid the foundation for this project. But it is open access, or I suppose, or open source. And so, anybody can download that data. I do need to make it, I guess, pretty. I am at the very basic. I'm at a very basic level when it comes to creating netcdf files, and so the attribute table is non-existent, but I have a README file that kind of details it. But yeah, so this is it's a high resolution gridded tropical cyclone precipitation product that I try to update every year, and it does, it's for the continental U.S., but it does look like that now that the 2020 season has been put to rest, I will have my work cut out for me when it comes to updating the product this year.
Oh wow! So you're updating this every year? Yeah, I'm looking at the most recent commits, and it was 11 months ago, which means you're coming up on the clock, huh?
Yep. So hopefully I'll probably end up I'll probably be a little behind schedule, just because I'm trying to write my dissertation. But look for updates, I suppose.
Well, that's fair. I think balance is what's important here. But if people are interested in just poking around doing some kind of data science, is this a good place to go? Just to kind of see?
Yeah, definitely.
Cool. Well, we'll include a link then in the show notes.
Yeah. Awesome. Yeah, that sounds great.
Yeah, I'm a big advocate for open source, open science stuff. So it's always really cool to see data being published in this way, because it can be so hard to get good data.
Right. I agree entirely.
Sometimes you have to get coffins.
Exactly. Which, we plan on putting that data up on the International Tree Ring Data Bank, I want to say, hosted by NOAA. So yeah, open access.
All right. Well, great. Well, Josh, thanks so much for being on Science Sort of today.
Thanks for having me.
We'll include links and everything. And yeah, hopefully we'll talk to you again, and you'll be in a tenure track position.
Awesome. Thanks. I appreciate it.
All right.
I hope so too. All right. Have a great day.
Yeah, you too. Thanks a lot. Bye-bye. Okay, so thanks again to Josh for taking the time to talk with us about his very cool work. I love the sort of like scrape it together aspect of the work, where it was like, okay, let's just find the data where we can find it. And it starts with trees, but then it goes to log cabins and, of all things, coffins. So I think that's very neat. It kind of shows us how there's connections to, like, the world shows us its history. And I thought that was really cool.
I also just I like how cavalier Josh is about sort of, I don't know, these samples were collected before I was even in school, but they're here. I'm going to use them. Like, there's a resourcefulness there, and sort of a, I'm going to roll with the punches and take what I can get and find some data in it is, I think, really ingenious and kind of inspiring.
Yeah. Yeah, no, absolutely.
So I'm very glad you agreed to do this, Tim. Were you nervous? Were you like, were you worried that I was gonna like not be happy with things, or that you were flying high without a net for the first time in your affiliation with us as podcasters? Like what how was this experience for you? How are you feeling?
Oh, thank you. Thank you for spotlighting me. I think no, yeah, I think the experience was mostly like, oh, but Ryan is the one who does these AGU interviews, and I want to make sure I don't like step on any toes there or do a bad job, basically. And then Ryan's like, oh, I always do much better when I do it, because your interviews in the past have been really good. And I always really like the atmosphere that when you're at AGU, that it's like this feeling of like, oh, well, we're all at the conference. Which was, of course, kind of a bummer to not get this time, but I wanted to try to recreate that feeling of like, okay, but like, you're talking about your science. It's like a fun convivial time here at this conference, even though it's all on Zoom.
Yeah, I will.
And I think it went pretty well.
Oh, definitely. I think you captured the style and the tone spot on. Really nailed it. And sort of, I can tell, not that I have like a particularly specific or well thought through interview style. It's sort of just my style that's evolved conversationally over the years of doing the show. But I can tell it's going well, at least in the way that I like to hear interviews, when like the next question you ask is sort of the question that I was already formulating in my head. And that definitely happened a couple of times listening through these. So I was really excited that, I think you nailed it.
Excellent. Yeah. And I hope that the listeners to this show also had that experience or got to enjoy it. And also are able to, I talked with Josh kind of towards the end of the interview a little bit about his experience doing stuff with Git and kind of collaborative science stuff. So I hope that if that's something that piqued anyone's interest, then they're able to follow up on that as well.
And I don't know if you've had much virtual conference experience over the last year. So like one of the first moments of the pandemic for me was a conference getting canceled. There was supposed to be a conference that Abe and I were both going to be at, actually out in Reston, Virginia, near the USGS offices where he works. And
Nice.
that was one of the first moments where like things were starting to get canceled in my actual life because of the pandemic.
Mm-hmm.
And then over the course, and that conference was just straight up canceled. There was not really time to shift it to a virtual format. There was a really good effort by some of the presenters to do sort of a tweet thread version of their talks around the same time that they would have been presenting, which I thought was a wonderful endeavor on their part and make the best of a bad situation. And I've done a few virtual conferences since then, and I got to admit, I don't know if it's my extrovert nature or just the distractions of being at home, but I really kind of struggle with them. Have you had to do any virtual conferences so
Yeah.
far, Tim?
No, I've had the same experience. I think one of the things that I like best about conferences is this feeling of immersion. It's this feeling that, like, for the period of time that I'm here, my entire world is thinking about this field or this topic, and everyone else is too. And the experience that I've had in virtual conferences, I've done, I think a handful over this year. I think I just kind of kept coming back because I was so thirsty for that conference experience. And I think people have done a valiant job trying to figure out how to make those spaces. But
Oh, definitely. Yeah. I don't begrudge anyone the effort of executing something like a virtual conference. It's a mammoth task that I'm impressed by what people are able to do. I just find myself personally having a hard time taking full advantage of the conference experience, exactly like you said, because, and I think you hit the nail on the head, and I hadn't put it in those terms of immersion.
Yeah, because I'll get off a conference at the end of the day, at the end of a conference day, and then I just put my headphones down, and then like I look over at my partner, and I'm like, I don't know, you want to watch Netflix or something? And then it's like it's not about the thing anymore. It's just, oh, back to reality. I guess I got to take the trash out.
Right, and it's it's like, oh, I got to start thinking about what I'm going to make for dinner. Whereas at a conference, like I'm committed to I'm going to eat at restaurants with people. I'm going to make that part of the meeting experience too, because that's a chance to catch up with different groups of friends and potential collaborators. And yeah, you're just able to go all in on being at the conference and kind of just put all the other distractions of life aside for a few days, hopefully, ideally, if that's a luxury that you have. And I just couldn't ever quite do that with these virtual ones.
Yeah.
And just the general Zoom fatigue. Anyways, for me, what's funny? I hadn't put this together until just now. I have no problem being like animated when I'm on the podcast talking with folks, like you and the other people who do the show with us. I have no problem being like a bigger version of my personality on the podcast. Maybe part of that is because I'm not on video, but I have a really hard time presenting on Zoom, and I say that as somebody who's now done my dissertation defense on Zoom. And it's just, to me, it is a completely it's just not the way I'm used to doing it, because I'm sitting in a chair at my desk. I'm not getting any real time feedback from the audience, either visually or audibly, and that's something I think I really rely on as an in person presenter. And so that's
Absolutely.
been really tough for me to adjust to as well. And you'd think I'd have some built in proficiency at that because of the podcast, but I actually don't think the skills translate as well as I thought they would.
Yeah, no. I was giving a talk last night, and a thing I've realized is that if you on Zoom, when you go to give a presentation, you go into share screen mode. They like pop out a little window for you can still look at other people's webcams, and I realized that if the wrong people are in that webcam and they're just, they're doing their own thing, or they're not like super engaged, I start to panic because I'm not getting any feedback. I'm like, oh, am I losing them? And so I've realized I need to like open up the grid on Zoom so I can see at least one person who is like giving me that visual feedback of like smiling, or kind of like they seem like they get it, and that feedback ends up being really, really important.
And people who listen to the show know that I'm the kind of person who, when it comes to cracking jokes, I take a lot of swings. I don't always get a lot of hits, but I take a lot of swings. And that's a sports analogy, Tim.
I haven't heard of it.
If you're hitting 3 out of 10, apparently it's very good. So I'll take those odds. And I almost think that like Zoom needs to institute sort of a laugh track feature,
I like this.
because I don't want people to unmute themselves. I find that very distracting. But
Mhm.
I'm the kind of presenter where, over the years of having presented, even in my science talks, I have jokes that I know hit, that I know I'm going to get a laugh and need a little laughter break or moment for people to chuckle. And they're not, it's not a stand-up show. I'm still presenting my science, but I just know like that's the way I present. I try to infuse a little bit of my own personality. My own personality is a person who tries to tell a lot of jokes. And so I need, when I get that dead air in those moments of my talk, it hurts. It stings real bad. So I need like in the reactions, all the reactions currently in Zoom are like visual. It's the little clapping hands and the little thumbs up. I need there to be just a little audio bump for a laugh track so that people can laugh at the appropriate time without unmuting themselves and give me that dopamine hit that I need to keep going in my talk.
This is something I feel like this is broken into a segment of Technically Speaking, where they used to try to do a fast, rapid design.
Rapid design, a perfect virtual conference.
Yeah, well, I think especially just even the like laugh track is like, yeah, maybe some kind of Zoom plugin that like when someone hits the little laugh visual icon, it plays just in your ears, a very quiet like.
Yep.
Yep. Very good. I like that idea. The other thing, I mean, if we're thinking about a virtual conference, the other thing I think that is really hard is that like hallway conversation idea, or that like, just bumping into someone. I've seen a lot of people try to do that, and I personally haven't really seen it done successfully.
Yeah, a few episodes ago, we had my buddy Lucas Joel on to talk about some of the reporting he's done. That was where we did the Myanmar Amber story.
Mm-hmm.
And he's a guy that like we went to school together, went to undergrad together, so we know each other pretty well. And then he's kind of shifted his career into this like journalism reporter space. And the last time I think I saw him in person was at AGU, but I was on the street. He was inside Moscone interviewing somebody, and I just tapped on the glass and like waved like like he was the rat in the cage. I was like, "Hey, Lucas, how's it going?" I didn't want to interrupt his interview. I wasn't planning to go inside the building anyway. But those moments where you just bump into somebody completely organically, it doesn't really. I mean, I guess it did happen in the virtual space with me and Josh. So
yeah, so that's something. I mean, that's a success. We'll call that a win.
Yeah, silver lining. Well, I would love to hear from other folks out there who have had. I presume there's so many different kinds of virtual conferences happening right now. I would love to get feedback from folks out there listening who have good examples of what works, funny horror stories of it all going wrong. Give us some feedback about your virtual conference experiences over the past year and how you think that they might be improved moving forward. And if you send that feedback to us, it might get featured on our final segment of the show, the PaleoPOW.
PaleoPOW.
The PaleoPOW is the final segment of the show where we tackle feedback from the listeners and delight in all of the wonderful things y'all send our way, including the wonderful thing that is a little bit of cash. And for that, we have to thank Rohit R, who has both set up a recurring PayPal donation going back for a long time now, so we were remiss in thanking him for that, but also has become a simultaneous Patreon supporter. So just wow, that's awesome, Rohit. Thank you so much for your continued support of the show. When we have a moment like that, I often just like to say that this episode is dedicated to or brought to you by Rohit R. Like that's and listeners just like you. But Rohit in particular, this episode is just a champion of Science Sort of for contributing and helping us out across multiple different platforms. If you would like to consider supporting us on Patreon, you can do so at patreon.com/science sort of. And I touched on this last episode, but I want to tell you, Tim, since last time I was just talking to myself, I want to let you know that Science Sort of is now an affiliate of bookshop.org.
Wow.
Did you know this?
I did not know this, actually.
Yeah, bookshop.org is a online book selling website, and I know that you're probably very familiar with a different, larger book selling website, but this bookshop.org website works with local bookstores in your area. So if you purchase a book through bookshop.org, it finds that book in stock at a local bookshop, and that's the person or that's the store that ships it to you. So you're lowering your carbon footprint because you're getting things shipped to you from a closer distance, more locally, and you're supporting your local bookstores in the process. And if you use our affiliate page, which is linked to on the website and also can be found at bookshop.org/shop/science sort of, if you buy anything through our portal, even if you don't buy the books that are listed, we have lists of the books that we've talked about, lists of the books that we've interviewed or authors that we've interviewed and their books. We get a little bit of that coin.
Well, would you look at that? That's beautiful. As far as I'm concerned, this is the bookstore of choice. Bookshop.org/shop/science sort of.
Obviously, the other river in South America has a lot more than just books, and so I'd be lying if I said I didn't still use it for that. But when it comes to just specifically getting books, I think this is a great resource. I'm all about supporting local bookstores, and I'm excited to be partnered with them as an affiliate. So go check that out if you need books, and who doesn't need a book?
Mm-hmm.
That's what I say.
Well, I want to say, go check out bookshop.org. That actually, I'm looking at the site now. This kind of rocks. It's got books we've talked about, folks who've been on the show.
Yeah.
And I also want to say thank you to Rohit going above and beyond. And I also want to thank Richard P, who sent us a voicemail. You too can send us a voicemail at 312-725-3672 or 312-PaleoPOWs. So let's listen to that voicemail from Richard right now.
Hi PaleoPOWs, it's Richard here from the UK. I'm a long-term listener to your show, and I don't ever remember you covering rodents. They've just eaten all the wiring in my house. Luckily, I'm an electrician, so I was able to fix it myself. Otherwise, it would have cost me a huge amount of money. But I was just wondering why they're quite so nibbly.
I don't want to be hyperbolic. That might have been the perfect voicemail. Said his name, said where he's from, gave us the situation that prompted him to call, and then asked a delightful question at the very end.
It's right there. It's grounded in real life. I love it. It's a great question. Ryan,
why are
rodents
they so
nibbly?
nibbly? Oh my gosh. Let's get into it. Let's get into the nibbles. There is an answer here. It might not be a satisfying an answer as Richard is hoping for, but this is something I can speak to. So, what do you know about rodents, Tim?
Well, they're small. Capybaras are the biggest ones.
Biggest living.
Oh,
They've
fair.
gotten bigger in the past.
Good point.
Deep time perspective, Tim.
Gosh, they're mammals.
They are the most.
They survived
diverse.
the dinosaurs.
I don't think there were true rodents. A lot of the early mammals look superficially like what rodents look like today, but rodents are their own distinct group of mammals. You are correct. They're actually the most diverse group of mammals. So about 40% of all mammal species are rodents.
Oh, wow.
Yeah, right? That's a lot.
Okay.
Rodents,
I think big teeth when I think rodents.
That's
where
that's definitely we're getting there. Okay. So rodents are their sister group are lagomorphs, which include rabbits, hares, pikas, things like that. That group is called gliers, Glires. One of the traits that defines the gliers are ever-growing incisors. So the incisors are the 4 teeth at the very front of our mouths. We have incisors. It's a common type of mammalian tooth. So it's the 2 teeth at the very front on top and the 2 teeth at the very front on the very bottom.
Yeah.
Lagomorphs, so rabbits, hares, pikas, are a little different in that they have a second set of incisors behind the incisors on the top. Rodents just have the 4 incisors. And the thing that is special about gliers is the incisors.
I'm sorry, Ryan, can we go back for a second? Did you just say that they have a second set of teeth behind their incisors?
Yeah. It's actually very easy to identify a lagomorph skull versus a rodent skull, and it's because if you look behind the top incisors, there are these 2 other little tiny holes where they have a second set of much smaller incisors.
Whoa. I still don't really have a great handle on like the concept of 2 rows of teeth. It really freaks me out.
Yeah, it's I think if we were more fish-like in mammals are weird when it comes to teeth. Obviously, like so much of mammalogy comes down to teeth, and part of that is because many animals in the world either have continual replacement of teeth or teeth that grow continuously throughout their entire lifetimes. So you think of like sharks going through thousands of teeth in a lifetime, crocodiles similarly. So it's actually kind of rare in the evolutionary history of mammals the evolutionary history of animals to have a group of animals like mammals that only produce 2 sets of teeth in a lifetime.
Really?
And that's actually and a big part of that is probably how much we chew. So if you think about it, like you don't really think of a crocodile chewing its meal because they don't have the teeth. They sometimes will have blunt teeth for like cracking open a turtle shell, but they don't really have like grinding surfaces for chewing, and they also don't have cheeks. Cheeks are a big part of the chewing story.
Whoa, you're right.
Right? Because you got to keep that food in there.
Mm-hmm.
So mammals, because we have all these various diets and all these different ways of chewing that food, have really specific teeth. And for some reason, it's this weird evolutionary trade-off where because teeth are an expensive type of tissue to grow, because enamel is a very dense mineralized tissue, many mammals have evolved having a set of baby teeth and a set of adult teeth, and that's it. There are some exceptions, because there always are. So if you think about like elephant tusks, those are a type of tooth that grows continuously throughout the elephant's lifetime. Those teeth don't have enamel on them because enamel is more expensive than dentin. So elephant tusks are just pure dentin.
Okay, so but rodents are always, or lagomorphs at least, are always growing more and more.
Just the inside.
Same
No, gliers. It's the whole group. Lagomorphs plus rodents equals gliers. Their incisors grow continuously throughout their entire lifetime. But it's the structure of their incisors that makes this particularly interesting. So when you look at a rodent tooth, so our teeth we have a core of dentin, which is surrounded by a shell of enamel, right? So if there's typically no dentin exposed on your teeth, if there is dentin exposed, you've got a pretty bad cavity and are probably going to need to go to the dentist because dentin is still innervated and it hurts if it's exposed. Enamel doesn't have nerves. It doesn't hurt. That's why we can chew on things and crack on things, and it's why our teeth are so hard and tough.
Yeah, they're just
so
like
what rodents have evolved, rodents and lagomorphs, but we're talking specifically about rodents here, they've evolved this really interesting structure to their incisor teeth. And they essentially, on the front of their teeth, so facing out of the mouth, they have a layer of pretty thick enamel. And then posterior to that, on the inside of their mouth, like where their tongue would be, lingual, they have a layer of dentin. And so it's, instead of a covering of enamel, it's a layer of enamel and a layer of dentin stacked on top of each other. And that grows continuously throughout the lifetime of the animal. And as the animal chews on things with its incisors, the dentin wears away faster than the enamel because it's physically softer, and it creates a chisel.
Oh.
So it creates a continuously self-sharpening chisel surface on their incisors. Does that make sense?
Oh. And so as it keeps growing, it's unlike a tooth that didn't grow. You might expect a tooth to get duller and duller over time, but because it keeps growing and it grows in this kind of asymmetric way, every time you wear it down, you're actually making it sharper. Is that right?
Yeah, it's an asymmetry of the hardnesses of the materials, right? So it's
Yeah.
more of a material science question than it is. I mean, it's also gross anatomy, but it's it's the material properties of the enamel relative to the dentin that create, and it's actually it's pretty stark. You can see this very easily, especially in some of the larger rodents like beavers. So I'm going to put an image in the Slack for you, Tim, and you can even just see that the colors of the two different tissues are pretty distinct and make this a pretty clear um, sort of structure.
Yeah. We're talking about the difference between like a light tan and a dark brown. So
Mhm.
it's really visually distinct. I didn't realize that was because it was like one was enamel and one was dentin.
And the issue here is if you're a rodent, you have to keep chewing those teeth. You have to keep wearing those teeth down your entire life because if the teeth aren't worn down quickly enough, because rodents have a pretty fast metabolism, so these teeth are coming. And if the teeth aren't worn down quickly enough, you can die because you'll reach a point where the teeth overgrow your mouth's ability to chew and even like grow into the skull of the animal. So there's some pretty horrific examples of these teeth sort of getting out of control and growing into places where they're not supposed to and causing some damage to the animal. So the reason rodents are so nibbly is because if they're not, they'll die.
Even if there's no nutritional value, it's actually it's kind of doing body maintenance. It's almost like they're brushing their teeth. It's kind of
Or trimming the nails maybe is a better analogy.
that
right?
is better. Yeah. They're
Like,
trimming their nails by destroying Richard's electricity.
and then so the larger question, and this was something I wasn't quite sure of when Richard asked, and I wasn't sure, is there some reason that rats and rodents chew on wires in particular? And this is actually a big problem worldwide. There's a lot of economic reasons to figure out if rodents and rats in particular are specifically drawn to wiring for some reason. And it does not seem that there is a clear answer. So the most obvious answer is they're chewing because they just have to be chewing. And if one of their things that they're trying to do is get inside of a human structure, because if it gets cold out, human structures are great for rodents because it's usually warmer, it's usually drier, it's usually safer from other predators.
Yeah, the same reason we like it.
Yeah, exactly. So if you're trying to claw and scratch and bite your way into a human structure and you're going through the walls, you're probably going to encounter some wires, right? And wires are a pretty good size for an animal like a rat. It's got these little hands, so it can actually grab onto the wire. It's a good size for it to get its mouth around. It's probably a combination of the fact that there are a lot of wires in human structures. They're a good size for rodents to nibble on, and they're in the way of the rodent trying to break into your house. So there was a huge study in Mumbai, India, trying to test all these different types of cables and wires and housings and coverings to see if there are types of wire coatings and cables that rodents prefer or seem to chew on more, or B, if they could find some way to like coat wires in something that makes the rodents not want to gnaw on them.
Mm-hmm.
It doesn't look like they have a ton of usable results yet, but it was a very large study. They included dozens of different types of cables, and it was all across Mumbai, so a huge sample size of rodents moving around. And I'm not picking on Mumbai; that's just where the study happened. I think you could do this in any city in the world, and you would probably see similar results. So yeah, rodents are so nibbly because if they don't nibble, they'll die, and the wires in our homes happen to be in the way and easy to chew through. So I think that's my answer.
That's a great answer. Honestly, that's so much. It's so great because it's like, yeah, that's a simple question, and it turned out to have a really deep answer that touched on evolution and construction, and there's a lot going on in there. That's great.
So I'm sorry about your house, Richard. You're not alone. But my building here in DC has had rodent issues as well. So it's just part of living alongside the natural world, I think.
And just know that you may have had to do a lot of electrical work, but that was in service of saving a rat's life, perhaps.
That is not a very convincing argument, I will say, but I appreciate that you tried, Tim. Well, Tim, anything else?
No, I want to say thank you again to Amato Evan and Josh Bregy. Those were great interviews.
Yes, thank you.
And for my part, if I'm plugging something, I'd like to say if you're interested in biology, automation, software, and collaboration tools, I've got a project that I've been working on and trying to publicize called BioArtBot. And you can just look for BioArtBot on YouTube, and there should be a couple of videos there kind of explaining it. And there should be ways to get in touch. And then also you can go to the website, bioartbot.org. So that's bio like biology, BIO, and then art like artistry, ART, and then bot like robot. So it's all there.
And we will link to that in the show notes.
Yeah. If you check it out and you're interested, be in touch with those channels, and we can all work together on some cool collaborative science.
And you're on Twitter, right?
And I'm on Twitter at Tim S. Dobbs.
Or would you rather people follow you on Twitch? Are you a Twitch guy now? What's happening?
Yeah, no, I mean, I have a Twitch channel, but I haven't been using it too much. But, always exploring opportunities. But yeah, check me out on Twitter. Come say hi.
I had a great afternoon hanging out with you and Ben and playing some Donkey Kong. It was fantastic.
Yeah, that's true. I mean, I don't know. I might get back on Twitch again, but right now, no comment at this time.
Okay, sounds good. I don't think I have anything to plug that hasn't already been plugged before, so just go to scienceorder.com, check out the show notes for this episode. We will link to Tim and I's abstract and poster. We will link to the abstracts and papers for the folks that we talked to, and we'll link to some gross pictures of rodents and studies happening in Mumbai, and yeah, just all the links you need.
And some gross pictures of green beer.
/shop/science sort of. The pictures of the green beer will be on my Untapped page. You gotta go connect with me over on Untapped.
There you go. For the people who really want it.
My beer logging endeavor, which I used to describe as Pokemon for adult men, but then they came back out with Pokemon for adult men, and we all started playing it again. So that joke doesn't work anymore.
Yeah, no, I remember that game, Pokemon for adult men, when it came out. I read about it in Nintendo Power for adult men.
Pokemon Go Somewhere Else, I think it was what it was called. All right, well, thanks for joining me, Tim. Thanks for doing these interviews, man. I really appreciate it.
Yeah, thank you, Ryan. Thanks for talking about them with me. A lot of fun.
Absolutely. Yeah, this was great. All right, well, come back next episode where you'll be sure to get a whole lot more science.
Sort of.
Visit sciencesortof.com for show notes, links to all the stories we talked about, and ways to interact with the hosts, guests, and other listeners. Science Sort of is brought to you by the Brachiolobe Media Network of podcasts, with audio engineering by Tim Dobbs of the Encyclopedia Brunch podcast. That's all for this week. See you next time on Science Sort of.
You ever done it like Sega? Sort of.
I think about it in terms of Sega a lot. I'm not gonna lie.
It fits in there.
I'm not gonna lie.
And then you could do that. I don't know if you remember, if you were a big Sega guy, but eventually they had one that was like, sort of.
What if Brachiolope and Sonic got married? What would that fan art look like?